In this video, we are going to cover the Cameroon GCE A-level curriculum for chemistry. We are dealing with many examination boards. We have the Cambridge International. We have the Cambridge International exams that is offering certificates like IGCSE, AS, and A levels. We are also dealing with the Assessment and Qualification Alliance, that is the AQA of the UK. We are also dealing with Edexcel of Pearson. We are also dealing with the Indian curriculum, which is the CBSE curriculum. And now we are covering the Cameroon GCE A-level chemistry curriculum. So today we are going to discuss specifically on the practical part of it. Looking at the Cameroon GCE A-level chemistry curriculum, there are entirely about 4 sections that are being covered. The 4 sections covered here will include, I have qualitative analysis, I have quantitative analysis, there is a rate of reaction, and there is enthalpy change measurement. For qualitative analysis, in qualitative analysis, it will involve the test for cations, involving the test for cations. It will also involve the test for. It will also involve the test for anions. Example like the halide ion. The halide ion. That is a reaction of chloride with silver ion, precipitates are formed, bromide ion, silver ion, precipitate are formed, iodide ion, and silver ion, precipitates are formed, and other anions. We will also be treating, under this section, we will also be treating a test for organic functional groups. Organic functional groups, where we will have to go into the carbonyl group, that is for ketones, aldehydes, and carboxylic acids, even in hydrocarbons and other organic compounds. So specifically, we'll be taking how to identify some specific organic functional groups in this section. Then we will have to go into a test for gases. We will have to go into a test for gases, and the testing of gases it will require a good knowledge. Your good knowledge in using the litmus paper to test the gas. If it is acidic, should in case the paper turns red. If it is alkaline, like ammonia, should in case the litmus paper turns blue. Then you also require a good your knowledge of using the lime water for the test for acidic gases like carbon dioxide. It will also require your knowledge on testing gases, reaction of acids and dilute acids and some metals, releasing a gas like hydrogen that it pops when it relights a glowing splint. So there's a pop sound that you see when hydrogen is being produced. So that will also require your good knowledge of it. Then I will also require the knowledge of rekindling a glowing splint. That is the test for oxygen gas, the test for it. So testing for gases is one of the area for qualitative analysis. Testing for organic functional group is another area. Testing for anions will be another area. Testing for cations through their solubility, whether they dissolve or they don't dissolve, and so on and so forth. So as we'll be going ahead, you are going to see a good example of this and past questions in the Cameroon GCE A-level chemistry. So you are going to see all this. So the second part of it will be quantitative analysis. Quantitative analysis, or what is usually called volume measurement or volumetric analysis. This has to do with the measurement of volume. One volume reacting, one volume we call it the titration, and the other one we call it the analyte, which is in the conical flask. So entirely we call it titration, and there are different types of titration in your exam. You could you might be given the acid-base titration. This has to do with what we call neutralization titration, to determine the volume of the acid that is acting with the base, and your knowledge of using the indicators. Another one will be a redox titration. This will involve oxidation, reduction, reaction. A common example are that of potassium, acidified potassium manganate 7 with iron 2 to determine the quantity of iron 2, maybe in tablets or in iron wire or anything like that. So you will use that in redox titration. Equations are needed. You need to balance your equation and calculations. So another type of titration that might come in your exam is precipitation titration. So this is another one that it can come. So overall, we can say under quantitative analysis or volumetric analysis, or what we call volume measurement, you are going to carry out a titration. So a good knowledge of your acid-base titration is needed. A good knowledge of your redox titration is needed. A good knowledge of the precipitation titration is also needed, because you don't know which one is going to come. Then another part of it is the rate of chemical reaction, how to measure the time. It is usually in seconds. Measure the time taken for a reaction for one substance to be used up. Usually it is sodium thiosulfate that is being used with the hydrochloric acid, but it all depends. So you should have a good knowledge of using the thermometer, your thermometer, a stopwatch, sorry. You use a stopwatch in taking the time. It could be a color change. It could be a formation of precipitate, when it has to do with sodium thiosulfate and hydrochloric acid to stop or making the cross under the conical flask invisible. So you will take the time, and your teacher must have taught you how you can use it and how to measure the time taken for the reaction. And you use the reaction, convert it into rate of into the rate. You use the data, that is the data in seconds. How you can use it, convert it into rate, and how you can use the plot the graph, and how you can use even the graph to calculate some other things. So a good knowledge of this area is also required. We will be coming to it. And finally, enthalpy changes. How to measure the energy change in a chemical reaction. You will also be taught how you can use the thermometer in a chemical reaction to see the change in the thermometer. When there is a change in thermometer, a change in temperature, sorry, a change in temperature, you will have the change in temperature from the initial temperature to the final temperature. You have the change in temperature. You can use this change in temperature after collecting series of data on it during your exam. You use the change in temperature to calculate the enthalpy change. Which using the formula, the MC theta, that is the mass of the substance you are using times the specific capacity of water and times the change in temperature. That is the energy change in joules. And you will use that. Then you can now remember that the enthalpy change is always in kilojoule per mole. So you will now use it and now calculate the enthalpy change per mole of that substance you are carrying out the reaction with. So by doing that, you will have the enthalpy change in kilojoule per mole. So for today, we are going to tackle. I'm going to show you how to tackle qualitative analysis questions in your exam. Before I go ahead, I want to thank those of you who have subscribed to our channel. I really appreciate you for a job well done. Then for those of you who have not subscribed, please, I am appealing for your support to like the video, share it to other fellow learners, then subscribe to our channel so that you will see other videos on our tutorial lesson. Thank you for that. Welcome back. Let's go back to our topic today. As I earlier mentioned, we are going to be tackling qualitative analysis questions. Now I have some guidelines beside what I have just given you. I have some other guidelines based on the Cameroon GCE A-level chemistry curriculum. You know, all the examination boards, they have different curricula. So in this, the basic concepts in science do not change, but there's only limitation. Some curriculum may lay emphasis on some areas and some may not do. But for this, for the Cameroon A-level, for the Cameroon GCE A-level chemistry curriculum, I am going to focus on those areas that emphasis is required based on some past A-level chemistry practical questions. I start with instruction on determination test. Instruction on determination test. A. When adding a solution to another in a test tube, remember the following. 1. Whether effervescence is produced, and if so, test the gas using a litmus paper. 3. Smell the gas produced. And A. Whether precipitates are formed, and if precipitates are formed, add to excess to see whether it dissolves or not. Observe the color formed. And all these, as you are observing this, make sure on the observation column of your question paper, state them out, because the answer scheme has all of them there. It's good to give out everything you see. The examiner will now select, because you might not know specifically what is needed if you can't understand the questions very well. So it is advisable to outline what you see. The D part of it, is it an oxidizing or a reducing reaction? B, when adding a solution this time around to a solid, when adding a solution to a solid in a test tube, remember the following: whether the solid dissolves or not, then add to excess. 2, color of the mixture in the tube, the color of the mixture in the tube. State it down. You can put it as precipitate. Okay, whether effervescence is produced, mostly when acids are usually added. You know, especially when acids are added maybe to solids like, let me say, a carbonate. You will see effervescence indicating the production of a gas, and carbonate usually produce carbon dioxide. If you are a smart student, if you are using a carbonate and you are using a dilute acid to tell an effervescence is observed, test for the gas immediately. You could use, if it's a carbonate, you could use lime water to test for it. Then again, smell the gas and test with litmus paper. Is it an oxidizing or reducing reaction? C part. On heating a mixture, on heating a mixture, recall the following points. Does the mixture dissolve when you are heating it? If not, heat persistently to see whether it dissolves. In case whether it dissolves, is a gas produced? And if so, test with litmus paper and smell it. In case the mixture containing the solid dissolves, it therefore means some ions are produced when you are testing for cations. I say, in case the mixture containing the solid dissolves, it therefore means some ions are produced and a gas is given off. Recall whether there is oxidation or reduction of the metal and non-metal. Note, it should be recalled that all metals are reducing agents. Non-metals are oxidizing agents. Only methanoic acid is a reducing agent. That is HCOOH is a reducing agent. When you are using aluminum foil, remember, in this occasion, as aluminum is a reducing agent, aluminum foil does the same. So wherever you are using aluminum foil, you have been asked to put in aluminum foil in and heat and observe or give inferences. Remember that as aluminum is a reducing agent, the aluminum foil you are using is the same, is also a reducing agent. It is important to mention effervescence if observed only when a solution is added to the other. In examination, when you are adding a solution to a solid, well, if you say fizzing is acceptable, if you say bubbles of gas is acceptable, if you say effervescence is acceptable by examiners. D. Some common tests, or there are some common tests or smells that are used in distinguishing organic compounds. You could be asked to distinguish some organic compounds that you are provided with. So there are some common tests used in distinguishing some organic compounds during experiments in the laboratory. And these include, some of these tests include a sour smell, Any organic compound that gives a sour smell, know that it is a carboxylic acid. Any organic compound that is giving a spirity smell, it smells like spirit, is an alcohol. Any organic compound that is giving a fruity smell, it smells like a fresh fruit, know that it is an ester. Any organic compound that is giving a fishy smell, it smells like a fresh fish, know that that is an amine, NH2. Then any other organic compound that has an antiseptic antiseptic smell, know that that is a phenol. It's a phenol. Then anyone that has a urine smell, smells like urine, know that it has ammonia in it. It's an ammonia gas. It has ammonia in it. Then when it has to do with colors, there are some complications. There are some complications when it has to do with reading colors of precipitate. Reading colors of precipitate and trying to describe the colors under your observation column. A color like apple green. Apple green. When you see a light yellow-green color, a light yellow-green color, no, your description there should be apple green color. When you see a deep yellow color in a solution, your description there should be orange yellow. So what is recommended is orange yellow, but you are reading it as a deep yellow color. What is also recommended is an apple green, but you are reading it as light yellow-green color. So these are some of the things you have to be very careful when reading and interpreting your result under the observation column of your question paper. As I said, when you look at this, you will be working with what we call your confirmation booklet. There are some confirmation booklet that they give. It all depends on the examination board. There are some confirmation booklets. We can call it for confirmatory tests. There are some data booklets. Many examination boards, they have different types. So whenever you are doing this, you should be working in collaboration or in line with what is written on the inference section of your confirmation booklet or your data booklet. So we go straight away to some of the past questions, some of the past Cameroon GCE A-level chemistry past questions, and how you can carry out all this, and how you can report your observation, and how you can report your observation, and how you can make a judgment under the inference column of the question paper. So now we are on qualitative analysis, precisely determination test 1 and 2. Determination test 1 and 2. Under determination test 1, this is a past question. Under determination test 1, you are provided with 2 salts, F and G, and an organic compound H. Carry out the following test on F, G, and H, recording your observations and inferences in the table. Then answer the questions which follow the table. A. Carry out a flame test on a small portion of F. on carrying out the flame test, I will recommend you on our previous video on flame test for cations, flame test for cation when provided with unknown salts. So go back, watch our previous video on flame tests. Remember, you need to dip on this flame test. Remember that you need to use nichrome wire. It doesn't react. That's why it is used. The nichrome wire, you need to dip it into hydrochloric acid. You need to dip it into hydrochloric acid. Then you will use that and take, since it is salt, you now dip it into where the salt is. Then you take it closer to the Bunsen burner where the blue flame is. Where there is a blue flame, because with the blue flame you can identify the color of the metal that is going to be burning. Only at the beside the blue flame, just near the blue flame, and you will see how the color burns. From the color you will identify, and then when you now see, when you get the color of the metal that is burning, okay, put it down on the observation column. Then go back to your inference booklet or your confirmation test booklet or your data booklet, whichever you are using. See which color, that color. Look at the cations there under the cations. Look at the cations and see which of the cation is giving the color you have observed. And then when you see the cation, you now go under your inference section on your question paper and put it there. In this case, I did the experiment and I observed that it was a golden yellow coloration. And under, in my booklet, I saw it was sodium ion that gives that color. So I say sodium ion present. That is how you state it. The B part of it, dissolve about 3/4 of F in 5 cm³ of water. Use that portion of the solution for the following test. To 2 cm³ of the solution of F, add aqueous sodium hydroxide and then a few pieces of aluminum foil and heat. Now, dissolve about 3/4 of F. Dissolve about 3/4 of F in 5 cm³ of water. Use portion of the solution for the following test. To 2 cm³ of the solution of F, add aqueous sodium hydroxide and a few pieces of aluminum foil and heat. Now, after I did that, I observed, following what I told you, the aluminum foil on heating dissolves. Remember, I opened the section of the booklet and looking at the inferences. Which one tallies with my observation? So you have to state it down. Aluminum foil on heating, aluminum foil dissolves. I told you, always observe whether a gas is removed, a gas is evolved or not. So there is evolution of a gas. Then I tested the gas. Then I say a smell of ammonia, and the litmus paper there is a smell of ammonia when I smell the gas. Then I use the litmus paper to test whether it is alkaline or acidic, and I tested it. Litmus paper turns blue. So I told you this is not stated in the question paper. It is your knowledge. When there is a gas being produced, you have to apply this so that you can get to the right gas. So under the inferences, I said NO2 minus or nitrite or nitrate present. So NO2 minus and NO3 minus are present. Ammonia gas is also present. I tested it. Then there is also sodium ion that is present. Okay. Now, to the remainder of the original of F, there was a section that you were asked to allow. To the remainder of the section of the original of F, add dilute sulfuric acid. Dilute sulfuric acid. Well, observation on adding the acid to it, bubbles of gas are evolved. And when the gas, as I told you, when a gas is being produced, you now have to test the gas. So I tested using a litmus paper, and what happened? I saw that turned blue litmus paper red. It's giving you, it's not telling you that it's something acidic. Then a light blue color of the solution is observed. On my booklet, what I saw and my conclusion was that sodium nitrate is present. Sodium nitrate is present. Now, D part of it, reserve about 1/4 of your sample of G for test G. To the remainder of G, and dilute hydrochloric acid in a boiling tube. Keep the resulting mixture or solution for a test E and a F. So it is to the remainder of G, add dilute hydrochloric acid. Add dilute hydrochloric acid in a boiling test tube. Then keep the resulting mixture for a resulting mixture or solution for test E and F. As I did that, there was effervescence that was observed. Colorless gas produced, and turned litmus paper red. Remember, anything that is turning litmus paper red is an acidic gas. The one that turns blue, it is an alkaline gas. And a good example of an acidic gas is carbon dioxide. And a good example for an alkaline gas is ammonia. If you had the opportunity, if you were provided with lime water, you could have even tested it there again. But make use of only the reagent and other material that you have been provided. So, in our inference, there was a carbonate ion that was present. There was evolution of carbon dioxide gas. Evolution of carbon dioxide gas. The E part of it, to 2 cm³ of the mixture or solution resulting from D, add aqueous sodium hydroxide. Add aqueous sodium hydroxide. I did that. That is what you are supposed to do. And when you do it, your observation is supposed to be what? White precipitate are present. And I told you, when you have precipitate, what should you do? When you have precipitate, when you observe, see, either you see the white precipitate clearly, or when you have a cloudy solution, those are white precipitate. When there is a cloudy solution, it is we call that white precipitate. When the white precipitate can be seen clearly, we also call it white precipitate. So be very careful the way you present your results. You read and interpret your results. So in this case, there was white precipitate that was present. I told you, you need to add to excess to determine the solubility, whether it dissolves or not. So in that case, what you need to do is you need to add in excess. So I added in excess, and what happened? Insoluble in excess. So on my judgment column, which is the inference section of it, what do? For the metals present that resulted in precipitate, I went to my inference section. There were many metals there. We have barium, cadmium, magnesium, and calcium that are present, ions that are present. Then the metal hydroxide, only metal hydroxide like this can produce that precipitate. Only metal hydroxide, or could be barium hydroxide, or it could be calcium hydroxide, because a metal hydroxide like this one, OH2, it means it's a group 2 metal. It's a group 2 metal. You don't have to be talking about group 1. As I've mentioned this here, know that the metal hydroxide that is present there is a group 2, because all of these are group 2 elements. So metal hydroxide present. Okay. So now it drives us to the F section of the question. The F section of the question says, to 2 cm cube of the mixture or solution resulting from test tube D, add dilute sulfuric acid. On adding a dilute sulfuric acid to this, while precipitate were formed, and as a tradition, you need to add to excess. While precipitate were formed on adding dilute sulfuric acid, and the white precipitate were insoluble in excess. So in that case, you go back to your judgment booklet, which is the confirmation test booklet or the book of data. It all depends what your examination board calls it. You will see the result, see the cations that are tallying with your observation. The one that tally with your observation, I saw it was calcium ion, it was a barium ion that were present. So these are the cations, and the SO42 plus that were also present. So G part of the question, carry out a flame test on a small portion of G. You are back now to a flame test. I told you how to carry out a flame test on a salt. Use nichrome wire, dip it into hydrochloric acid, and then you use it to pick. You use it to carry or to put it into the salt. When you put it into the salt, it will carry some salt in it. So the little salt that will attach to the nichrome wire will be placed beside the blue section of the flame, the blue flame of the Bunsen burner. From there, you can observe the color of the flame. So I did it, and the color was what? Look at the reading. Crimson. Crimson is a deep red or a bloody red. Anything that is deep red or bloody red, we call it crimson color. Crimson color. And on the inference page, I saw that the only metal that can give a crimson color is I think strontium, which is SR2+. That is the cation that will result. So it is SR2+ that was present. Now, H part of it, place a few drops of H. Place a few drops of H in an inverted crucible. Place a few drops of H in an inverted crucible lid and ignite it from above. Ignite it from above. Now, I will advise you should be used to all laboratory equipment. All the apparatus used in the laboratory, you should be versed with them. And in one of my previous video, there is there is a display of all those of the apparatus that are used in the laboratory, and what what they are used for. So go to the previous video, look at experimental skills, experimental techniques in the laboratory. On my previous video, you will see all this, what this is used for, what this apparatus is used for, and so on and so forth. If you know it, you should not. You should know what is an inverted crucible lid. So place a few drops of edge in an inverted crucible lid and ignite it from above. So I did that, and the observation was burns readily with a flame of low luminosity. That it burns with very low yellow flame. It burns with very low yellow flame. And any organic compound, any organic compound that burns like that, it has a low carbon hydrogen ratio. It's a lower one. And in that case, it is an aliphatic compound. Or maybe having between 4 to 5 carbon atoms. For instance, that is to say, are residue left or not? When you do combustion of organic compound, check to see whether some residues are left. And do they melt or not? When it has to do with organic compound, always try to see whether they melt, the residue they melt or not. Number 3, during combustion of organic compounds, observe whether it burns easily. Whether it burns easily or it burns with difficulty. It takes time before it burns. That is luminous. When it burns easily, we say it is luminous. It is luminous with smoky or non-smoky flame. Number 4, always cross-check whether the conclusion drawn in the inference columns and the conclusion drawn in the inference columns and the observation made are correct from the confirmatory tests. There are confirmatory tests that are given to you in the booklets. So always when you are working, as I said, you will always be cross-checking the confirmatory tests from the booklets for all classes of organic compounds. Now, it takes us to the last section, which is determination test 2. Test 2. Under determination test 2, you are provided with a salt A and aqueous solution of salt B, a salt and aqueous solution of salt B, and an organic compound or organic substance C. Carry out the following tests on A, B, and C, recording your observation and inferences in the tables. Then answer the questions which follow the table. Question number 1A. Carry out a flame test on A. That was done. What I observed was that a gold yellow, or what we call orange yellow color of flame observed. Gold yellow, orange yellow color of flame observed. Of course, you will definitely have sodium ion that is present as your inference. When you do that, it takes us to the B part of it. The B part of it, dissolve half of your sample of A in 5 cm³ of distilled water. To 1 cm³ of the solution of A, add a few drops of aqueous potassium manganate 7, and which has previously been acidified with dilute sulfuric acid, and warm the mixture. Keep the rest of the solution for test C and F. After I did that, there was what we call a rapid coloration. A rapid coloration. To 1 cm³ of solution of A, add a few drops of aqueous potassium manganate 7. You know the color of potassium manganate 7. It is purple color. It's a purple color. So on adding it, there was a rapid decoloration. So on my inference booklet, compounds that can possibly do this, we call their OH, containing the OH group, containing the aldehyde group, and we also have the alkene group. The alkene group. Group having reducing properties, and they will decolorize this one. So these are the only group of compounds that can decolorize the purple color of the aqueous potassium manganate. Aqueous potassium manganate has a purple color. It has a purple color. When you add this there, what happens? It will decolorize it. It will decolorize it. Why do I say that it will decolorize it? Even when we're doing alkenes, we saw that only alkenes can decolorize acidified potassium manganate 7. When they decolorize acidified potassium manganate 7, what happened? It means that all the alkenes have reacted, and all the manganate 7 have reacted. They do that by reducing manganate 7 to manganate 2. When there's decolorization of the purple color, that means manganate 7 has been decolorized from +7 to +2. It has been reduced from +7 to +2. So remember that alcohols, aldehydes, and alkenes, they have reducing property. Potassium manganate 7 is an oxidizing agent. It can oxidize these compounds. Then these compounds, they have reducing properties. They will reduce potassium, acidified potassium manganate 7 to manganese 2. So when there's that decoloration, when there's a change in color from purple to colorless, it means reduction has taken place. It means manganate has been reduced from +7 to +2. And by who? By any of these compounds. So when I referred to my inference booklet, I saw that only compounds having OH, CHO like aldehyde, and alkenes can reduce manganate. They can decolorize manganate So we now say A is a reducing agent. A is a reducing agent. Now, A is a reducing agent. To 2 cm cube of the solution of A, add a few drops of aqueous mercury chloride. You are provided with mercury chloride. Then you have to add it to A. We have discovered that A is a reducing agent that reduced the manganate, and we said it could contain an alcohol group, it could contain an aldehyde group, it could contain an alkene. So in that case, if we now add mercury to it, heat the mixture to boiling, and continue boiling for about 3 minutes. When we did that, white precipitate of mercury chloride are formed, turning from what? From gray-black as mercury chloride is reduced. White precipitate are formed. That is, they are turning from what? From gray to black. Then we realize that the metal there is also the strontium ion, cation. Then the G part of it, to 2 cm cube of the solution of B, add aqueous sodium hydroxide. And my observation was a red-brown precipitate of iron 3 hydroxide. Iron 3 hydroxide was formed. A red-brown precipitate of iron 3 hydroxide is observed and added to excess as according to our tradition. It is insoluble in excess. And with FeOH3, so the cation, the ion present there would definitely be what? It would definitely be the ion 3 plus that is present. The ion 3 plus that is present. I drove us to the E part of it. the E part of it, to 2 cm cube of aqueous sodium ethanoate. Add a few sodium ethanoate. Add a few drops of the solution of B, and boil the resulting mixture. So the observation was white to yellow precipitate are formed. It's only ion 3 that can do that. F, to 2 cm cube of the solution of A, that is the reducing organic compound of A, add a few drops of the solution of B and boil the resulting mixture. Now, I did that. The observation was brown precipitate were formed. And under my inference, reduction is taking place because I said A is a reducing agent. Reduction is taking place, methanoic acid is present, and the methanoid ion are present. Methanoid ion are present. Now, it took us to the G part of it. To 1 cm cube of the solution of B, add aqueous silver nitrate. Then add dilute nitric acid. You see that the observation on adding aqueous silver nitrate, a white precipitate of silver chloride are formed. That is an indication of the presence of chloride ion in the substance. White precipitate of silver chloride are formed, an indication of chloride ion that chloride ion are present. White precipitate persists on adding distilled nitric acid or insoluble in dilute nitric acid. Again, silver chloride precipitate observed. Now, the H part of it, to 2 cm cube of the solution of B, add a few drops of aqueous potassium thiocyanate. Aqueous potassium thiocyanate. Then add aqueous tin 2 chloride. I did all this. My observation was that there was a very deep blood red coloration, indicating the presence of ion 3 ion. There was also the solution becomes clear on addition. The solution becomes clear with SnCl2. This is an indication that the ion 3 ion is reduced to ion 2 since the blood color disappears. Ion 3 reduced to ion 2 since the blood color disappears. Now the I part of it, transfer about 1/4 of carbon to an inverted crucible lid. Transfer about 1/4 of C to an inverted crucible lid. Heat it from below, and when fumes begin to be evolved, ignite it from above. I did that. I saw that there was low luminosity, that it burns with difficulty. Low luminosity, burns with great difficulty, chars, and with a smell of burnt sugar. I told you a smell of a burnt sugar is indicating the presence of starch or glucose, anything like that. So burnt with a smell of burnt sugar, and does not even melt. Under the inference column, my inference is possibly it is a carbohydrate or a hydroxyl acid. Starch is present. Now, dissolve a small quantity of C again in 5 cm cube of water. Filter if necessary. Test the solution with red and blue litmus paper. I did that with water, no effect on red or blue litmus paper. If there's no effect on blue or red litmus paper, we cannot talk of acid, we cannot talk of alkaline, so we say starch is present. Starch is present. K. To 2 cm cube of the solution of C, add about 10 drops of aqueous sodium hydroxide. Then add 1 cm cube of copper 2 sulfate solution and heat the resulting mixture carefully. When I did that, no reaction with sodium hydroxide. Then with copper 2 sulfate, a blue solution formed with copper 2 sulfate. Indicating what? The blue solution in copper 2 sulfate is showing that copper 2 ion is reduced to copper 1. The blue solution with copper 2 sulfate solution shows that copper 2 is reduced to copper 1. Then, add 2 cm cube of solution of C, 1 cm cube of dilute hydrochloric acid. Boil the mixture for 3 minutes. Then neutralize the solution and repeat test K. Observation: a dark brown precipitate is formed. Again, copper 2 ion is reduced to copper 1 ion. Now answer the following question. Suggest an identity for A and C. From all what we have been saying, A, the ion, the cation shows that it was sodium ion. And we went further, it also showed it was sodium. So based on our inferences on the different stages, we can now conclude that the identity for A is a sodium. That is a sodium metal. Then, our conclusion for C, we have observed the test for C. We have observed it could be sugar. We don't know exactly the type of sugar. Is it a reducing sugar or non-reducing sugar? So finally, based on the inference column, we can now conclude that the identity for C is starch. It is starch. That was GCE 1991 practical exam on the determination test. Fellow learners, for more details on qualitative analysis and past questions, please copy this link and watch it. Copy this link and watch it. You have more details. You will see the lab work. You will see the colors. And you will see how we can draw inferences from our observation. But remember, by doing it, you have to, we are just pleading for you to like our video and subscribe to the channel. I just want to remind you that for the titration and conclusion, you are also reminded to watch our previous videos. Watch our previous video on acid-base or neutralization titration and also redox titration. We have previous video there. Try and watch it. Subscribe while you are watching, please. But we will still have some other questions to treat on this area. Then above all, you have a list of some other links that you can share with your friends. You can share this link for acid-base past exam revision questions. You can go, you can share, you copy this link and you observe it. There are links there, 3 links, you observe it. links for qualitative analysis past exam revision question. You copy it and put it on YouTube. You observe it. Links on the red dog titration past exam question part 2. You will still see them there. You observe them. But remember to like when you are doing it. Share. And do not forget to subscribe. I'm wishing you the best of luck in your exam. Have a nice day. Thank you for watching.